Hello everyone. Let me introduce myself. My name is Anggi Juliana. I'm a student of mathematics education from Universitas Pendidikan Indonesia. First of all, I would like to say thank you for this opportunity, and I will present my paper with the title Learning Obstacles in Solving Geometry Problems based on Special Ability in terms of handhield level. The first one is Introduction. Geometry. Geometry is a mathematical concept that is very close to student life. Geometry can help students to improve their ability to think logically and rationally, improving the truth of an equation. Based on this, geometry is a part of mathematics that can improve students' ability to solve problems in their lives logically and rationally. One of the abilities that can support good and correct geometry learning is the spatial ability. The spatial ability is the ability to capture and understand something through the five senses, namely the first one is spatial perception, second one is spatial visualization, the next one is mental rotation, spatial orientation, and spatial relation. Based on this, the five spatial abilities can help students to be able to solve problems in everyday life logically and rationally. Based on Van Hill theory, when student learning geometry, student will go through five levels of thinking, namely level 1 or visualization, level 2 or analysis, level 3 or informal deduction, level 4 or deduction, and the last one level 5 or rigor. Based on this, each stage of thinking will show the character of the student, thinking's process in learning and understanding the concept of geometry. So that if students have difficulty in learning geometry, the thinking stage can identify what difficulties are experienced by students. But in reality, students often have difficulty when learning geometry, and students often have difficulty to identify geometric image. One of the previously identified student errors was that students were wrong in stating that the roof of the cube was in the form of a parallelogram or a rhombus. Based on this, students are less able to recognize and understand geometric image or object correctly. So, this will hinder students from achieving a correct understanding of geometric concepts. The obstacle that occur in the learning process can be called as learning obstacle. This learning obstacle can be categorized into three types, namely ontogenic obstacle, second one is didactical obstacles, and the last one is epistemological obstacles. Ontogenic obstacles are learning obstacles related to students' mental readiness to learn. Didactical obstacles are learning obstacles experienced by students based on how the teacher teaches. And the last one is epistemological obstacle, or learning obstacles related to the limited application of knowledge possessed by students. Based on this, these learning obstacles can affect student learning so that it will affect this understanding and mastery of mathematical concepts, one of which is geometry, so that this obstacle need to be identified so that teacher can try to make new design that can later be used to overcome this obstacle. Based on this description, the goal for this research was conducted to determine the special ability of students and to explore the learning obstacle experienced by students in solving geometric problems based on special ability in terms of Van Hill's level of thinking. The next one is research method. The research method used is descriptive qualitative, which means that this research is scientific in nature and there is no attempt to manipulate the data in this study. The participant in this study consisted of 60 students and mathematics teachers. Several students who can represent are selected for further depth interview. The data collection technique in this study was carried out by using a special ability test, depth interviews to all participants, and document analysis. The data analysis technique used is triangulation. The overall data obtained is then reduced by grouping the data based on the student answer, so that student special abilities are obtained in solving geometry problems, then linked to the results of interviews and document analysis based on Van Hill theory to identify student learning obstacles. The next one is the result. Based on the 5 special abilities of students, which include spatial perception, spatial visualization, mental rotation, spatial orientation, and the last one, spatial relation, the research not only analyze spatial abilities based on the answer from the instrument test results, but also consider the reason given by student when answering problem on the instrument test and when interviewed. Okay. Student special ability based on Van Hill's level, and in the first one is the spatial perception. Based on Van Hill level of thinking, students are at level 0 can be represented by S5 who is not able to visualize the cuboid seen from above, while level 1 can be represented by S1 who is able to visualize the stack of cubes when viewed from the right, even though it is wrong to solve the problem by ignoring other images. The next one is spatial visualization. Based on Van Hill's level of thinking, students are at level 0. Students are not able to visualize the geometric shapes requested in the question, while at level 1 or visualization, students are able to visualize the geometric shapes on the basis of how they appear on the picture. The next one is mental rotation. Based on Van Hill's level of thinking, students are at level 0. At level 0, students are not able to visualize the geometric shapes requested in the question, while at level 1 or visualization, students are able to visualize geometric shapes on the basis of how they appear on the picture. The next one is spatial relation. Based on Van Hill's level of thinking, students are at level 0. At level 0, students are not able to visualize the geometric shapes requested in the question. Level 1 or visualization, students are able to visualize geometric shapes on the basis of how they appear on the picture. While at level 2, students are able to know the relationship between geometric shapes that appear in the problem. And the last one is spatial orientation. Based on Van Hill level of thinking, students are at level 0, where students are not able to visualize the geometric shapes requested in the question, and while at level 1 or visualization, students are able to visualize geometric shapes on the basis of how they appear on the picture. Based on the first spatial ability, namely spatial perception, students are expected to be able to understand geometric objects both horizontally or vertically. And based on the result of the study, there are still students who are wrong in answering the question of spatial perception. The question is given a picture of a cuboid with rectangular sides, and students were asked to choose which picture represent the cuboid when viewed from above. And this is the student's answer. When the interview was conducted, the student stated that picture A represented the cuboid when viewed from above based on what he saw. The next one is spatial visualization. Based on the second spatial ability, or namely spatial visualization, students are expected to be able to know change in geometric object from 3 dimensions to 2 dimensions or vice versa. Based on the result of study, it appears that there are still students who are wrong in answering questions regarding spatial visualization. Students are asked to determine the correct image of the cube nets given as shown in the following figure. We know from the cube's net, the opposite side with the black circle is the white star. The opposite side with the white square is the black star, and the opposite side with the white circle is the black square. But this is the student's answer, and we can see this one. In the front of the cuboid is the black star. After that, the opposite of that side is the black circle. Okay. Based on this answer, S3 seems wrong in determining the cube based on the cube nets in the problem. The next one is mental rotation. Based on the third spatial ability, namely mental rotation, students are expected to be able to rotate geometric objects precisely and accurately. Based on the result of the study, it appears that there are still students who are wrong in answering questions regarding mental rotation. The problem asks students to describe the result of a 180-degree rotation of the object. From this object, and this object is rotation 180 degree. So this is the student answer. And however, the result of the S10 answer show that there are still students who are wrong in visualizing the object in the question. The next one is spatial relation. Based on the fourth spatial ability, namely spatial relation, students are expected to be able to understand the arrangement of objects and their parts and understand their relationship to one another. Based on the result of the study, it appears that there are still students who are wrong in answering questions about spatial relation. In this question, students are asked to determine the angle on the cube before and after it is rotated. We know that the angle of the corner point of cube is 90 degrees, both before and after rotation. But in this student's answer, Esther chose option A because Esther sees that the angle of BAD before rotation, this is before rotation, looks sharp. So Esther determines the answer based on what he sees, not based on the properties of the cube. The next one is spatial orientation. In spatial orientation, students are expected to be able to identify the shape and position of geometric objects from a certain point of view. In this ability, students were asked to describe the stack of cubes when viewed from the front after being rotated 90 degrees clockwise, up and up after being rotated 90 degrees counterclockwise. Okay. The result is as two steps that because if the front view is rotated, the top view is rotated. And the top view is rotated, the stack of cubes looks separate, even though the stack of cubes is the same only in different position. In addition, there were some students who could not answer the question because it was difficult to imagine it. The next one is student learning obstacle result. The results show that there were learning obstacles both ontogenic, didactic, and epistemological experienced by students in solving geometric problems based on special ability in terms of fun-hill level of thinking. First one is ontogenic obstacle. The ontogenic obstacle identified in this study are ontogenic obstacles that are conceptual, instrumental, and psychological. Second one is didactical obstacle. The didactical obstacle identified in the study was the lack of use of teaching aids in learning mathematics. And the last one is epistemological learning obstacle. The epistemological obstacle identified when students are less able to solve problems that are out of context. The conclusion is based on the exposure of the result of the research and discussion, it was found that students who experienced learning obstacles in solving geometric problems based on special ability were at level 0, level 1, and level 2 at the Fun-Hill's thinking level. The learning obstacle identified from students who experienced error in working on geometric problem based on special ability are ontogenic obstacle, didactical obstacle, and epistemological obstacle. That's all from me. Thank you for your attention.